All right, guys. So today, day one, we're gonna do variable on both sides. Even though these equations are gonna look a little more complicated, we are using the same exact guidelines that we took notes on before. We're gonna get started here. I'll do 3 problems for you. Pay attention, rewatch this video a couple times if you need to. Here we go. Number 7 is gonna be the first one I'm going to do. Again, it may look complicated. I will just follow my guidelines. Guideline 1, parentheses. Do I have any? I do not. I can skip this step. My life's easy. 2, combine like terms. Always make sure we're on the same side when we're combining like terms. So here is my equal sign. I'm gonna look at each side individually. On the left side, it looks like I have 3 terms here. 1, 2, 3. Out of these 3, these guys would be like terms. Why? These 2 have a variable. This 5 does not. So I'll be able to combine these. And then also on the right side, looking at these 1, 2, 3, 4 terms, it looks like these 3 are all numbers. These 3 have no variables. So I can actually combine all of those. But this 1p right here has a variable, so I cannot, he can't join the party. He's pretty lame. Now let's take care of this. And when I combine like terms, you just add them together. So I got a -2 plus a -3. You can, it'll be a little bit tricky for some of you guys if you don't believe me. -2 plus a -3, that gives me a -5, -5p. I'm gonna bring down this +5 because I have not used it. And don't forget my equal sign. Now, we got a -15 plus 3 minus 1. Okay, we have a -15 plus 3 minus 1. That's gonna give me a -13. Bring down my plus 1p, or just plus p, doesn't matter. And there we go. There's no more combined like terms to take care of. Guideline 3, get your variable on one side. If it's on both sides, which we're gonna have, we have to get it to one side, and it doesn't matter what side we wanna put it on, as long as we addition, subtraction to move those terms. So when I say that, I mean this. I see a -5p on the left side, a +1p on the right side. It doesn't matter if I wanna move this one here or that one there. As long as you do it correctly, you'll still get the same answer. So I guess I'm just gonna move this 1p to the left. I'll be a little weird today. So you gotta use addition, subtraction. I can either +1p or -1p on both sides. I wanna do the opposite, so I'll do -1p here, -1p there. Notice when I put it on the left-hand side here, I lined it up with the term that it would combine with. They both have variables. I wouldn't put the -1p underneath the 5 because you couldn't combine those two. Now let's take care of it. At -5 minus 1, -6p. Bring down my +5 equals, since those cancel, I'm left with just a -13. And now we are at guideline 4, isolate the variable, move our constant first by addition, subtraction, coefficient second by multiplication or division. So with that said, let's do it. Variables on the left side, I move this 5 here because that's my constant. I'm going to -5 from both sides. That cancels. So I get -6p equals a -13 minus 5. You can double check my work in a calculator. That'd be a -18. Divide both sides by -6 because that -6 is a coefficient and it says -6 times p, so I do the opposite, so I divide both sides. So these divide out, p equals -18 divided by a -6. That's going to give me a +3. And again, I know I moved fast through this problem, but you guys should have some of these skills under your belt already. But there we go, p is equal to 3. I won't check my work either because I'm trying to save some time. Let's move on to another more complicated one. Let's do problem like, it looks less complicated, but we'll see. Number 11. First things first, follow my guidelines. Guideline number 1 is parentheses, fancy multiplication. We gotta make sure we distribute. Well, I have parentheses here. So I'm gonna go ahead, I'm gonna take this -3 and I'm gonna multiply it. Sound effects really help. And I'm gonna multiply. So I'm gonna multiply and write down my answers. -3 times a -4. Double check me in a calculator. That's going to give me a +12. A -3 times a +2r. Well, I'm going to take care of the numbers first, and the r will go along for the ride. -3 times a +2. That's going to give me a -6, and the r goes along for the ride. Bring down the rest. Haven't used it yet, so I just bring it down. Now the parentheses are done. I looked at combine like terms. Same side, and again, you're not always going to combine, but we'll check it out. On the left side, variable, no variable. Out of these two, I can't combine these two. On the right side, again, no variable, variable. I can't combine these two. So when it comes to combining like terms and looking one side at a time, I can't combine anything. So my life is good. I can skip guideline number 2. Number 3, get your variable on one side. Again, it doesn't matter what side you put the variable on. You just gotta use addition, subtraction to move your variable piece. Well, I moved my variable to the left in the last problem, so I guess I'll just move it to the right in this problem. As long as you do it correctly, it does not matter. A minus 6r, I do the opposite, plus 6r. Those cancel out. I drop down my 12, drop down my equal sign, drop down my 18, and then you can double check my work in the calculator. Negative 3 plus 6, that's gonna give me a positive 3. Don't forget the r. And now, again, we're at our 2-step again. First, constant, addition, subtraction, then you move a coefficient by either multiplication or division. Well, my constant, okay, I'm looking at this right side here because that's where my variable is. Constant 18, so it's a positive 18. So I do minus 18 on each side. 12 minus 18, that's gonna go ahead and give me a negative 6. The 18s cancel, and I can drop down my 3r. That's a coefficient. In this case, I'm going to divide both sides by 3. Those divide out. R equals negative 6 divided by 3 is a negative 2. Again, I'm not going to check my work for time's sake. There we go. Beautiful. It's a masterpiece. 15, word problem. These word problems are a little bit different. We're getting better at word problems, so I'm not going to talk as long. But here we go. We got container A and container B having leaks. Container A has 800 milliliters of water. It's leaking at 6 milliliters per minute. Container B has 1,000 milliliters and is leaking 10 milliliters per minute. How many minutes will it take for the containers to have the same amount of water? All right, we got a couple things going on here. First off, we got 2 different containers. We got container A and we got container B. Container A has 800 milliliters of water and is leaking at 6 milliliters per minute. Container B has 1,000 milliliters of water and is leaking 10 milliliters per minute. Well, let's go ahead and just kind of, go straight to sorting out this information. So container A, I'm just gonna write this out mathematically, has 800 milliliters of water, and it's losing, so minus, right, it's losing, subtraction, 6 milliliters per minute. I don't know how many minutes we're talking about, so I'm gonna give it a variable. I'll just give it M for minutes. 800 milliliters to start off with, minusing 6 milliliters for every minute that goes past. Container B starts off at 1,000 milliliters, and it is losing 10 milliliters per minute. So notice how I just took my information from container A and container B and kind of just wrote out a little expression for each. Here's where things get super cray-cray. The question says, how many minutes will it take for the containers to have the same amount of water? Whenever you have a question, a word problem, talking about the same amount of water, how much will it take for them to be the same, equal? This is your small trick. And what you do, you're gonna take each expression and you're just gonna set them equal to each other. I wanna know when container A will be equal to container B, when they'll be the same amount. You just set them equal to each other. So now I'm gonna rewrite it even though I don't have to. I have myself a nice multi-step equation that if I solve, I'll find out exactly the minute at which both these containers, which start off at 2 different levels, will be the same exact level. So here we go. Use my worksheet. Parentheses, do I have any? No, I can skip it. Combine like terms, let's check it. Equal sign on the left side. 800 has no variable, 6 has a variable, can't combine it. On the right side, 1,000, no variable, 10 variable, I can't combine anything. Look at that, life is super easy. I don't have to do step number 2. 3, get your variable on one side using addition or subtraction. Well, I do have a variable on 2 sides, which is a no-no, so let's see if I did right, left, I'll do right again. I'm gonna move this 6m to the other side. So it's a minus 6m, I do plus 6m. Again, I'm gonna put the 6m in alignment with the term that it would combine with. I can't put it underneath the 1,000 because I can't combine a non-variable and variable term. Those cancel. 800 equals 1,000, negative 10 plus 6. That's gonna give me a negative 4m. And now I'm literally just going to finish this out. Move my constant by addition, subtraction, move my coefficient by multiplication and division. So let's do it. Here's my constant, number not attached to a variable. It's a positive 1,000, so I do minus 1,000 on both sides. 800 minus 1,000, that's going to go ahead and give me a negative 200 equals, those cancel, and I got my 4m right there. Now I'm running out of room here, so I'm just gonna rewrite this. Okay, move my coefficient to negative 4 times m, right? So in this case, I'm gonna divide both sides by negative 4. Negative 200 divided by negative 4 gives me 50. That's my answer. And what this means is at 50 minutes, both these containers, even though they start off at 2 different levels and they're leaking at different rates, At 15 minutes, they'll have the same amount of liquid or water inside of them. Well, there we go, guys. That was a lot of fun. Rewatch this video if you need to. Good luck with your homework. Have a wonderful day. Stay healthy. Stay safe.